So a warm welcome for listening to this particular lecture on chain drives. So this is one topic which is present in your module 2, that is after belt drives. There is a wire rope topic, and after the wire rope is the concept related to chain drives. It is part of your module 2, and some questions may come from chain drives also in your external exam. So here I'll be mainly going through, in this presentation I'll be mainly going through the introduction part of the chain drives, including the design of chain drives, and later in another lecture I will solve one particular problem on chain drives. So we'll go through the introduction first. So coming to the concept of chain drives, as you know very well, so chain drive will mainly consist of an endless chain. It consists of an endless chain, as you can see here, which will be wrapped around two sprockets. It will be wrapped around two sprockets. So in belt drives, if you have observed, there was pulleys, flat pulley, V-belt pulley and all. So here instead of pulleys, we will be having sprockets. The term used is sprocket, which is a cylindrical wheel which will have some kind of tooth profiles on the periphery of those two cylindrical wheels. On its periphery, toothed profiles will be present. Okay, so that kind of arrangement is called as sprocket. Okay, the front view of this particular chain drive arrangement is clearly explained here. Okay, so if this is the driving shaft on which the sprocket is connected, then that sprocket will be the driving sprocket, and using chain we will have to transmit motion as well as power to a driven sprocket. Okay, we have to transmit power. So that is the main reason for chain drives, that is the transmission of power. If you have idea in detail about the belt as well as a rope drive, in those belt and rope drive we have seen that slipping may occur. There are high chances for that slipping to occur. So in order to avoid such slipping in applications, steel chains can be used. In such applications, if we have to avoid the slipping, then we can go for chain drives. As you can see here, chains are basically made up of many number of rigid links. They are made up of many number of rigid links which will be hinged together by pin joints. So how it is joined and how the connections are basically made, we'll see in the further slides. So it is basically made up of many number of rigid links connected by pin joints. Okay, and these pin joints actually provide necessary flexibility for the transmission of motion, as it can be wrapped around the driving as well as the driven sprocket wheels. Okay, these joints actually provide necessary flexibility for the motion to be transmitted. Okay, so and regarding the wheels, if you observe clearly, they have some kind of a projecting teeth of some profile. They have some kind of projecting teeth, and when you observe, it actually fits into the recesses present in the links of the chain. You can observe in this particular image, it actually fits into the recesses which are present in the links of the chain. Okay, so that's why the teeth are provided. So in detail regarding the joints and what are the different components used to make these links, we will see. So in basic, chain drive is basically made up of a series of links which are connected by pin joints, and these chain drives has some certain features related to belt drive and has some features of gear drives as well. Okay, both features are present in this particular concept of chain drive. So coming to the advantages and disadvantages of chain drives when you compare with the belt as well as the gear drives. Okay, there are certain merits and there are certain demerits as well. So what are the major merits? We'll see what are the major advantages. One is chain drives can be used for long as well as short distances. That is the center distances, that is distance between the driver and the driven wheels. So from operation, chain drives are actually more preferred and suitable for medium center distance. That is in the case of gear trains and all. If the distance is long, then we may use a simple or compound gear train. Let's say simple gear train, where in between we use intermediate idler gears, which will help to transmit the motion or power. So if the distance is slightly longer than the gear trains, then in such applications we can use chain drives. We can use chain drives. And one more advantage is using only one driving sprocket. That is, if there is a one driving shaft and we'll fit a sprocket to it, so that sprocket will become a driving sprocket. And using one driving sprocket, we can drive many number of shafts. That is a major advantage in chain drive. Using one driving sprocket, we can drive many number of shafts using the chain, either in the same direction or even in the opposite direction also we can drive. So using one driving shaft, we can drive multiple driven shafts if we are going to use chain drive in such applications. That is a major advantage. And when you compare with belt drive and all, it has a very small dimensions. It is small compared to belt drives. Hence, it will result in a very compact unit. And as I said, the chances of slip in chain is very less when compared to belt drives. So chain drives can also be termed as a positive drive, similar to gear drives. It can also be termed as a positive drive. And regarding the efficiency of the chain drive is very high, and it is even higher, up to around 96 to 98%. But in order to maintain that efficiency, the chains need to be properly lubricated. If proper lubrication or regular maintenance is not there, then the efficiency will come down. Okay, and even the initial tensioning, that is regular maintenance with tensioning of the chains need to be done, or else the efficiency of the chain drives will be lower, or it will come down. Okay, or else the efficiency is very high. So those are the certain advantages. So regarding the disadvantages, if you compare with the gear drives, gear drives inside a housing, it will be operating under full lubrication. In major applications, it will be operating with full lubrication. But chain drives does not operate under full lubricant film between the joints. There is no presence of full lubricant film. So hence the wear will be higher in the case of chain drives. Wear generated will be higher, and even the wear will be present, especially at the multiple joints of the chains. There are many joints, so wear will be present at those particular joints. That is especially between the link and the bush, what we say. At those points we will see the wear. Okay, and due to this wear, what happens is the chain will get extended. Due to this wear, we have observed that the chain will get extended, and when the chain gets extended, there are chances that it may leave the sprocket. So tension of the chain needs to be adjusted from time to time, so that it may not leave from the sprocket. That is one. And one more is, it is not suitable for non-parallel shafts. It is not suitable for non-parallel shafts. If you have observed in bevel gears, worm gears and all, those gears are basically used for applications where their shafts are non-parallel in condition. But chain drives cannot be used for such applications. That is a demerit. And one more is polygonal effect, and one more is requiring housing. Definitely you know that you have seen in multiple applications it requires housing. And one more is, compared to belt drives, the alignment of the shafts on which the chain drives are mounted needs to be accurate. Precise alignment of shafts need to be present. Then only the efficiency of the power transmitted will be higher. And as mentioned before, we need to provide necessary tension, that is the sagging of the belt, what you have seen in belt drive. Similarly, there will be slack in the or sagging of chain also will take place. So in order to reduce that sagging or slack which is taking place, we may need to use a tensioning device. So proper maintenance and regular lubrication needs to be present in these types of chain drives, or else it will result in the generation of noise also. So regular lubrication needs to be present, or impacts also will be more, and wear will be more, and if wear is more, then it will where it will come out of, or it will leave the sprocket teeth. So these are the certain merits and demerits of the chain drives. So coming to the next concept, I have missed about saying the applications of the chain drive. So as you have
Seen in multiple applications, chain drives are very popular in the transportation industry such as bicycle, motorcycles, automobile vehicles and all, right? And even they can be used in metal as well as woodworking machineries, right? So in such applications, we might have mainly seen it in applications such as what is that, chainsaw and all. Chainsaw, in such applications, chain drives are used, right? And even in agricultural machineries and especially material handling equipments and all. So in such applications, chain drives will be used. And regarding the parameters such as velocity ratio, speed and power, chain drives are usually used if the velocity ratios are less than 10:1. If it is less than 10:1 and the velocity is up to 25 meter per second can be attained in the chain drives, and up to a power of around 100 kilowatt, chain drives are able to transmit the power. Okay, this is the concept related to velocity ratio, speed and the power. So coming to the different types of chains, as I said, this is not the only type of chain which will be present. This is not the only type of chain will be present. There are multiple type of chains, and multiple chains has multiple purpose. So with respect to the purpose, chains are classified into three types. One is hoisting and hauling chains. One more is conveyor chains, and another one is called as the power transmission chains. So these are the figures for the hoisting and hauling chains. Okay. So these chains are mainly used, let's say, for raising or lowering loads, to raise, that is to pick up and lower the loads or objects or components in a material handling equipment. So for that, those purposes we use these hoisting and hauling chains. You must have seen these chains everywhere, right? So a popular type of chain in this type is this type of link chain. This is called as the link chain. Okay, and there are two types of links. Either the chain can be generated with oval links. The chain can be generated with oval links. You can see the links of this type of chain is of oval shape. And how it is manufactured, you can refer some YouTube videos. Some interesting YouTube videos are present. So one link is connected to another link, and the joint of each link is basically welded, right? So how it is made, you can refer that. So the one link will be connected to that, and the joints are welded. Okay, and the sprockets, there are sprockets which are used for these types of chains, and the sprockets will have receptacles to receive these links. Will have receptacles to receive these links, and you might have seen these types of chains we used for in marine applications, such as in the anchors. In the anchors and all, the size will be very large, not the small sizes and all, but very large size chain links are used especially in anchoring of the ships, right? For when the anchoring is taking place, or you're raising the anchor also, how the operation is taking place, you can refer, and what is the size of the chains also, you can get it from internet. So in such application also we can use these types of chains. Okay, that is, one is oval shape, as I said, oval shape, and one more shape is there, that is, it can also be of the shape of a square shape. Okay, it can also be manufactured in a square shape, but they are used for lower load applications, uh, which are mainly used in either hoists or in dredging applications, even in cranes and all. In such applications, we can use chains woven with square shapes. Okay, so for those applications, we go for the hoisting and hauling chains, mainly for the raising and lowering of the loads. Second one is the conveyor chains. Conveyor chains, as the term suggests, it is mainly used for carrying materials. It is used for carrying materials, let's say by sliding or pulling or carrying in conveyors. So up to a speed of 2 meters per second, these chains will be able to carry materials in conveyors or other forms. Okay, up to around 2 meters per second, the operation can be carried out. You can see these types of chain conveyors in any production industries, like in food processing industries, or let's say any packaging industry, such as Amazon, Flipkart, any packaging industry. If you see, wherever there is automation, that is, if the industry is automated, you can see these types of chain conveyors being used. Okay, in such industries, conveyor chains are normally used, and it is widely used right now. So that is the application of conveyor chain, and one more is the power transmission chain, based upon which our focus will be. Okay, our numerical solution will be mainly based on the power transmission chain, and this one is you are very much familiar also, which is mainly used for transmitting power from one shaft to another shaft. Okay, and they are usually used when the distance between the centers of both the shafts is medium or short. If they are too long, then the transmission of efficiency in these types of chain drives will be lesser. And as I said, only the efficiency of the chain drives will be high only if there is a proper provision for efficient lubrication to be taking place. Efficient lubrication, that is, lubrication must be present. Okay, proper lubrication need to be present, and these types of chain drives can operate for speeds above 2 meter per second also. Even above 2 meter per second, we can operate these types of chain drives. And these chain drives are further classified into 3 different types. So as I said, power transmitting chains can be basically classified into 3 types, such as block type chain drive, or block or bush chain. One more is a roller chain drive, or can be called as bush roller chain drive. And last one is a silent chain or inverted chain drive. These are the major 3 classification of the power transmitting chains. Okay, so first one, let's go one by one. So one is the block or bush chain. So the schematic representation of the block chain drive is clearly shown here. Okay, so these types of chains, let's say when this power transmission concept was in its early stages and all, okay, when it was in early stages, so in those early stages, these types of chains were used in chain drives. This was the type of chain which was actually used for power transmission when it was in its early stages. Okay, and these chains, what it was found is, when these chains, when it approaches the teeth on the sprocket or leaves the teeth, there is found to be noise generated during the motion. When the teeth approaches or leaves the teeth of the sprocket, noise is generated because there is a rubbing between the teeth and the links. There is a rubbing between the teeth and the links. So that is what demerits which is found in this type of block or bush chain. You can see how it is made. Okay, so here this is an inner plate, this is an inner plate, and this is an outer plate, and this is an outer plate, again an inner plate which is connected by 2 outer plates. So inner plate and outer plate are interconnected using a pin. Okay, or else you can say this as a block and this as an outer plate. This is interconnected using a pin. This is connected using a pin. Again it is connected using a pin. Again it is connected using a pin. Pin is present here. Okay, so these chains, basically they are simple in construction. They are simple, but the problem is they are heavy. and the efficiency is also lower, and these chains you can normally see in bicycles and all. Okay, in bicycles these chains are normally used, but they are slightly heavier and less efficient. So this is the construction related to block or bush chain. I'll not be going in detail regarding the silent chain, that is the inverted chain drives, that you can refer yourself. Our concentration will be more on the roller chain. Okay, our concentration will more focus about the roller chain. So coming to the roller chain concept, so as it is mentioned here, so let me say first of all, so this entire thing, this one, and this entire thing together, we will call it as a one chain link. Okay, this is entirely, we'll call it as a one chain link from here till here. There is one chain link, and similarly this will be another chain link. Okay, this will be another chain link. Next you can see the major components. I will go one by one. So this chain link and this particular chain link, they are interconnected using an outer plate. So this one is called as an outer plate. This is called as an outer plate. Okay, next one, as you can see here, another plate is also present. Here another plate is present, and that plate is called as inner plate or inner link. They are called as inner plate or inner link. Okay, and the other things, so as you can see here, in this particular place, basically there is a bush that is present. Bushing is basically present here, and on the circumference of the bushing we will be placing a roller. On the surface of the bushing we will provide a roller. Why roller is provided means because when the rollers engages with the teeth of the sprocket, it will have smooth motion, and the wear which will be generated will be very less, and the stresses generated on the bushing also will be less if you use rollers on the surface of these bushings. So as I said, bush is present, and above the bush there will be a roller. Similarly here, bush is present, above which a roller is there. So bush, roller, especially the bush, this bush is press fitted to the inner plates. This bush, inside the bush is present, it is press fitted to the inner plate at this end, and it is press fitted to the inner plate at this particular end. Okay, so bush is present, above which a roller is there, but the bush is press fitted to an inner plate at both the ends, and this link is connected to another link using an outer plate. How it is connected? It is connected using a pin. It is connected using a pin, and this pin, you can see here, it passes through the hole which is present in the bush as well as in the roller. Roller as well as bush is hollow, so the pin will pass through it, and pin is press fitted to the outer plate as well as the inner plate and the bush. Pin is press fitted to outer plate, inner plate, bush, inner plate and outer plate. So this pin provides the necessary flexibility for the chains to be wrapped around the sprocket wheel. So same schematic diagram is shown here. So as you can see here, so this one is the bush. Around the bush there will be a roller. Okay, and this bush is fitted to an inner link plate on both ends. Here also inner link plate. Okay, then as I said, this is the outer link plate which is shown here. So this is the outer link plate. Outer link plate is connected to a chain link using a pin. You can understand how the roller is. This is the D1 is the diameter of the roller. Okay, same is here. So this is the outer link plate, this is the inner link plate, and first what you see is the roller. Inside the roller there is a bush, and through the bush hole we will be passing through a pin. And one more thing you need to know, that is the term called as strand. That is term called as strand. In your bicycle and all, you will be using only one strand chain. Strand chain means only this particular thing. Only one strand of chain you will be using in bicycles and all. So this entire thing is called as one strand for transmitting the operation. That is like number of belt we are using. We used to calculate how many number of belts we need to transmit the power. Similarly, this is one strand. This will be, if this also you include, this will be two strands, and total it is three strand. In this particular figure which is shown, there is three strands of chain, 1, 2 and 3. Three strands of chain. In heavy application and all, we need multiple strands to transmit the power. One strand will not be enough, whereas in your motorcycles, bikes and all, one strand is present. Even in bicycles also, one strand is used. So there will be application, and even in numerical problem we have to calculate how many number of strands is present. So strands means 1, 2, 3. Similar number of bells. So that is the concept related to roller chain. So as you can see here in detail, again the section view of the roller chain is presented. So all the geometric relationships, equations are basically related with respect to the roller chains. Okay, so this is the bush which I was talking about, and it is press fitted to an inner plate, and this bush will also be press fitted to another inner plate, and a roller will roll around the bush. Okay, and this is the outer plate, and this is the outer plate, and it is fitted using a pin. It is fitted using a pin. So this is the image of that. I think I missed out one particular concept which needed to be explained. That is the concept related to pitch. I cannot go back to the previous figure. So as I said, if there is wear taking place in the chains, if wear is taking place, then the chain will get extended. When the chain gets extended, basically a parameter called as pitch of the chain also increases. The term called as pitch also increases. Pitch is basically nothing but it is the linear distance between the axis of the adjacent rollers. So let's say from here till here, that is the pitch. Okay, axis of the adjacent rollers. It is the linear distance between the axis of the adjacent rollers. So when the chain gets extended, the pitch also increases. When pitch also increases, the rollers will not fit equally into the cavities of the wheels, and the chains will come out of the sprocket wheel. It will come out. So pitch plays a very important role in chain drives. When it gets extended, it is the pitch that will be increasing, and if pitch is increasing, then it will not fit properly into these cavities. It is basically the linear distance from one axis of one roller to another roller, or axis of one pin to another pin. So coming to the geometric relationships, you can see here, this is the chains which is engaging with the sprocket wheel. So we'll go through certain terminologies. So capital D is nothing but the pitch circle diameter of the sprocket wheel. Now you might be already familiar with the pitch circle diameter of gears and all. Similarly, this is an imaginary circle, okay, based upon which the teeth will be generated. That is the pitch circle diameter, capital D. And one more is the pitch angle. Pitch angle can be measured with respect to the vertical axis. If you draw a line passing through the perpendicular line passing through the axis of the rollers joining the center of the sprocket wheel, the corresponding angle generated is called as the pitch angle. It is the pitch angle, and the pitch angle can generally be obtained if you consider the entire circumference, that is 360 degree of a wheel circumference. So 360 degree divided by number of teeth which are present on the sprocket, you will get the pitch angle. 360 divided by number of teeth on the sprocket will give you the pitch angle that need to be measured. Okay, and pitch is the linear distance which I already explained, and pitch circle diameter, you can go through this derivation, simple one. Okay, that is, this is d, means this is d by 2, and this is uh, p, and how, if it is alpha by 2, what will be the equation. So pitch circle diameter, we can develop it in this particular form. Okay, and this is the velocity ratio, which is the normal velocity ratio which we normally use in all our calculations. So 1 and 2 suffix are mainly because it is not one particular driving wheel we will be considering. We will consider driving sprocket as well as the driven sprocket. So that's why N1, N2, Z1. So the average velocity of the chain drives, we can obtain it using this particular equation, and these equations are present in your data handbook. Okay, so no need to worry, all these equations are there. Much detail about the derivation is not required. You can refer other textbooks if you need to learn for the derivation. So the length of the chain, so length, the total length of the chain will always be represented in terms of how many number of links which is present and what is the pitch value. Number of links I have already told you, one link, two link, next, and each link is connected by an outer plate. So how many number of links will be present multiplied by pitch will give you the total length, and number of links in a chain can be determined using this particular formula, which contains the center distance as well as teeth and the pitch value. That will give you the number of links, ln value. And in order to calculate the center distance between the driving and driven sprocket, we will use the following equation. We'll use this following equation. So how to solve this, we'll see in our numerical solution. So coming to another concept related to power rating. So in practice, power rating of the roller chain is based upon the 4 failure criteria. This is the 4 criteria based upon which failure will normally take place. So the 4 conditions are: 1, it is may be due to wear, it may be due to fatigue, impact, or galling. So what are those conditions? We'll just go through briefly. So first, coming to the concept of wear. So it is a normal concept. Due to friction, wear will take place in the chain, and wear is normally caused and observed at the joint portion of the pins and the bushings. At the joint portion of the pins in the bushings, wear will be observed. So when wear takes place, as I explained before, elongation of the chain takes place. When elongation takes place, the pitch of the chain will increase. So when pitch increases, elongation takes place, the chain will ride out of the sprocket teeth, right? So that will happen if the wear is more. So when elongation is too much, then we'll have to replace the teeth. So only way you can reduce the wear is the chain has to be properly lubricated. If there is a good lubricant film layer present in the chains, then the friction generated will be lower, and if friction generated is lower, then the wear also will be low. That is one way. That is the way you can reduce the wear. The second one is the fatigue. So regarding fatigue, if you observe the motion of the chain continuously passes around the sprocket wheel, right? Similar to belt drive, if you observe, there will be a tight side and there will be a slack side, right? In belt drive, there will be a tight side and there will be a slack side. So similarly, in chain drives also, there will be a tight side and there will be a slack side. So in the tight side, the tension force or the tensile force acting will be very high, whereas in the slack side, the tensile force acting will be very low. So there is continuously fluctuating loads which are acting on these chains. When fluctuating load come into picture, it rightfully will generate the fluctuating stresses. And if fluctuating stresses are present, it will definitely lead to fatigue failure, especially in the side link plates. Okay, so if fluctuating load or stresses come into picture, then fatigue failure will definitely take place. And one more is the impact. So when the rollers, it continuously engages with the sprocket, there is always an impact action that is taking place. So when there is continuous impact and if the load is very high, then it may lead to breakage of the roller or the bushing. So we have to make note of that. The material chosen must be very good and the number of teeth has to be taken into account. The chain tension needs to be proper so that the impact action can be reduced. So those points need to be taken into account. Last one is the galling. So it is basically a stick slip condition which is experienced between the pin and the bushing regions. What happens is when the tension which is generated is very high, in some regions, especially in the joint portion of the pin and the bushing, some small micro welds will be generated. Welds will be generated. And due to continuous relative motion between contacting surfaces, these welds will break off. And when these welds break off, it will not go on its own, it will also take some material from the surfaces of the plates as well as from the rollers. So when it takes some surfaces, especially from the pin surface or outer plate surfaces, it will lead to wear. So when it happens, again the first concept, it will lead to the extension. So if there is proper lubricant, then we can prevent the galling condition also. Okay, and the power rating equation of a roller chain is provided here. So next we'll come to the design concept of a chain drive. That is, what are the important rules that needs to be considered in the design of a chain drive. So there, as it is given here, one is the number of pitches, or let's say number of links in a chain should be even. It should be in even number. At the same time, the number of teeth on the driving sprocket should be odd. Number of links should be even and number of teeth should be odd. Why this odd even? Mainly because that also odd, especially to number of teeth in the driving sprocket. Why? Because odd number of teeth in the sprocket in combination with the even number of chain links is found to provide a uniform wear condition. The wear is found to be uniformly distributed over each and every teeth. So if we choose the combination of odd number of teeth and even number of links, then there will be uniform wear over all the number of teeth which are present in the driving sprocket. So that is actually practically better. Where will take place? Definitely, if there is a lubrication, if there is less lubrication, then wear will take place. So it is better that the wear will take place at each and every juncture than the wear taking place at a specific point. If one tooth the wear is more, then it may result in failure, even though all the chain links are proper, or even though all the remaining number of teeth are proper. One teeth, if it gets failed, then the entire component needs to be replaced. So better than that, in order to extend the life of the particular component, if we are able to distribute the wear over each and every tooth, then the life of the particular component can be increased. So that's why we are going with the odd and even combination. And when in studies it was observed that if even number of teeth was used in the driving sprocket, even number of teeth when it was used, then it was found that let's say there is teeth 1, teeth 2, teeth 3, teeth 4. Okay, let's give a number to each teeth. If even number of teeth was used, then the first teeth and the third teeth is found to have greater wear. First teeth and third teeth is found to have greater wear, whereas the intermediate, that is the second teeth, that is the second teeth is found to have lesser wear. So the alternate teeth, let's say teeth 1 and teeth 3 has higher wear, whereas the intermediate one, teeth 2, has lower wear if we are going with the even number of teeth in the driving sprocket. So that is not uniform distribution. So if you want in a uniform distribution, then you have to go for this particular combination. Next, the concept regarding the positioning, that is the drive arrangement positioning. So chain drives can be arranged either in vertical or in horizontal position, but as far as possible, vertical chain drives need to be avoided. Why? Because you can assume this is a sprocket which is present here. Sprocket is present here, and at the bottom there is another sprocket which is oriented in vertical condition. Vertical orientation is present. So in the case of a vertical drive, you can just assume, as I said, there will be sagging, that is slack will definitely take place in a chain drive. So if there is a slack that is taking place, then the chain which is wrapped around the lower portion of the lower sprocket, the chain which is wrapped around the sprocket which is at the bottom, that chain will ride out of the sprocket very easily, right? The chain will come out of that sprocket at the bottom if we are going to use vertical chain drive, right? That is one major disadvantage. So if you have to eliminate that sagging condition, then we have to provide necessary tension. Then we need to provide necessary tension so that it won't cause an outward shift of the chain. Okay, that's why horizontal chain drives are more commonly preferred. And also another preference condition is, if you have observed in if you have observed in belt drives, if you must have noted, tight side is present at the lower portion of the belt drive. Tight side is present at the lower side, and slack side is present at the top portion. Where when you come to chain drives, it is more preferred that tight side is at the top and slack side is at the bottom. The preference is given if the tight side is at the top and slack side is at the bottom. Why? Because if you are going to provide a slack side at the top, let's say in chain drive, if you are going to provide slack side at the top, then during operation this sagging portion of the chain will engage with the teeth on the sprocket. This sagging portion of the teeth will engage with the teeth on the sprocket and will result in lower power transmission. That is one issue. This sagging portion will engage with the teeth on both driving and driven sprockets. Another thing is, if you are going to transmit power over very large distances, if you are going to transmit power, then there might be chances that the sagging portion of the chain at the upper end will come in contact with the chain which is present at the lower end. The sagging portion of the chain which is present at the upper end will come in contact with the chain at the lower end when you are going to transmit power over large distances. That also is a possibility. So considering those possibilities, it is preferred that slack side is at the bottom and tight side is at the top, so that even if slack is there, it will not further engage with the teeth on the sprocket, causing a lower power transmission. And also when you are transmitting power over large distances, slack side won't come in contact with the tight side. So if you observe in your motorcycle and all, so slacking will be usually taking place at the bottom portion of the chain drive, and that's why when it hits the housing, the unusual sound you will be hearing. And immediately if sagging is there or slack is found, then you have to pre-tension the particular chain so that such a noise and sagging can be eliminated. And what is the type of device and type of options available to tension the chain? You can refer the textbook. There are certain small concepts which are mentioned, so I'll not go through that in. So coming to the last concept before the design procedure, that is the one important concept related to chain lubrication. So friction, as you know, is a major factor which influences the efficiency of chain drives. right? Friction will further result in wear. So due to friction, there will be frictional losses taking place, and there are multiple reasons by which the frictional losses is happening. So frictional losses can mainly be due to, one is friction between the rollers and the bushes, right? On the bushes the rollers are placed. Even if the roller is rotating around the bush continuously, even there is significant amount of friction that will be present. And another frictional loss will be due to friction between the bushes and the pins. So inside the bush there will be pin, and definitely bush is a fixed part and pin is also a fixed part. So there will be significant amount of friction when the relative motion is taking place in the chains. So there will be friction between bushes and the pins which is inserted inside the bush. And the last one is the loss due to friction between the sprocket teeth and the rollers. So when the chain is wrapped around the sprocket, there will be significant amount of friction between the rollers which is coming in contact with the cavities of the sprocket teeth and also in contact with the faces of the sprocket teeth. So there also friction will be generated. Okay, so these are the different means how the frictional losses is generally noted, and it is found out that if the contacting surfaces or if the chain drive itself is very well lubricated, then the efficiency will be very high, up to around 96 to 98% can be attained. And in case if you are not going to lubricate it well, in case if the chain drives are not well lubricated, then the efficiency will be low. So this was what I have explained in the beginning. So what are the advantages by proper chain lubrication is, one, you can reduce the frictional heat, you can reduce the frictional heat, you can reduce the frictional losses, you can reduce the wear of chain components, even you can protect the chain against the rust as well as corrosion, and even the shock loads, that is the impact loads acting on the chains, can be eliminated by providing proper lubrication. So what are the different methods through which the lubrication of chains are possible is given here. So it is given as type A, B, C and all. So each type has a particular name. Type A is either a manual or drip lubrication. Second one is bath or disc lubrication. Third one is oil stream lubrication. So coming to first one, that is manual lubrication. So manual or drip lubrication. So manual lubrication means, specifically manual lubrication means, the lubricating oil which is present will be applied to the chain links using a brush or a oil can after every specific duration of operation. After a certain duration, let's say 10 hours or 15 hours of operation, we will be applying the lubricating oil using a brush or a oil can to these chains. That is the manual operation which we normally do. One more is the manual is the one which we usually do. We apply the grease or we apply certain kind of oil to the nowadays a spray lubricants is also there which can be applied to the chain drives. So that is the manual one which we apply every now and then so that the motion will be very smooth. Another one is the drip lubrication. In drip lubrication, actually a small drip lubricator will be present in the system. A small drip lubricator will be present, and from the drip lubricator we will be continuously supplying oil to a horizontal pipe, and this horizontal pipe will have holes in it, and through those holes oils will come and fall onto these link plates, similar to the drip irrigation system which you know. So a horizontal pipe which will have holes, and through those holes oil will come and fall onto these link plates, and from and to the horizontal pipe we will be supplying oil from a drip lubricator. That is the drip lubrication or manual lubrication condition. That is a type A lubrication. Type B is little more high end, that is called as a bath lubrication or disc lubrication. One is the bath. In bath lubrication, what is usually being done is the lower side of the chain will be made to pass through a, let's call a tank or a sump which will contain the lubricating oil. The lower side of the chain will be made to pass through a sump containing lubricating oil. Okay, so that the chain will get immersed in this oil, and then go and get wrapped around the sprocket. So if it is sagging portion is present there, every time the sagging portion will come and dip into the chain, or even if it is properly tensioned also, it will be